Well, hi, good morning. Thanks so much for joining me here in my shop for another bit of battling with this radio. I have a little bit of a story to tell. I didn't post a video yesterday, but not because I wasn't in here. Yeah, I was in here, and the story was so sad, I did not want to post it. But it ends on a good note because I came in last evening and sort of corrected what I had done. So here's the story. I set out to do an alignment on the radio. I have the dial face. This part of the story is fine. I'm just showing you what I did. I lined it up. There's a mark there for the get the pointer position correct, and just move it all the way there. Turns out this mark does match a mark that's on here. Someone previously must have done it, maybe even in the factory. Huh. Maybe this is the answer to the whole story here. I'm going to carry on with my story and then I'll explain my So I then applied marks. You can see a mark here. These are represent the locations where alignment, where the alignment instructs you to tune the radio. So I marked it. I put this in the radio cabinet. I have the cabinet. I put the radio in the cabinet. I then set the pointer according to the dial. I then removed the receiver from the cabinet. I then placed the dial in the correct position once again based on where the pointer is sitting now. And then I noticed that this dash line lines up with this. So from then on it's kind of simple. I'm just checking it. For instance, this one's at 1500. Great. I moved the string. I moved the pointer on the string to the right spot. That's right. Maybe I've discovered my mistake here already. Okay, wow, okay, I found my mistake. Oh my gosh. So here's what went on. Oh my gosh. I'm not even telling you what I did wrong, but I will in a moment. So using these marks, I tried to align the radio, and what I found was I could not get the local oscillator to come down low enough to align the radio properly. So in other words, 1500 ended up over here. 600 ended up over here. Nothing I could do would fix that. There's the capacitor trimmer right there, right here. I open that thing wide up and can't get it to move any further. I then went on what I realize now is a wild fishing trip in a lake with no fish in it. My gosh. But I did find something very interesting, which I will show you shortly. What is my mistake? Oh my gosh, here's my mistake. Yeah, this edge of this carriage here, the pointer carriage, does line up there. But that's not where this dash lines up. The dash lines up where the pointer is sitting. When I raised up the glass, I went, What I realized was the glass is not centered. It should be over here. Oh my gosh, there's nothing wrong with this radio. It's me. Once again. My gosh. Oh boy, oh boy. Well, the good news is I'll be able to align this radio properly. But let's take a look at the interesting thing I found, because I will go through the alignment. In fact, let's start warming up a little more equipment. Pretty cold in my house this morning. A little colder outside now. So turning on lots of equipment. Good thing. Get some radiant heat happening here. Well, let's take a look at the weird... if you're hearing some thumping in the background, that's the sound of my cats running around upstairs playing together. All silent now, of course. Let's take a look at this weird... well, not weird thing, interesting thing I found here. Okay, one we look at the schematic for this radio. I don't think I've commented on this before, but maybe I did. Let's go a little bigger. This capacitor here is a real oddball. If you look at the labeling, bubble number 5 is sitting here with an arrow pointing to this transformer. This is the local oscillator transformer. But it's also pointing up at this capacitor. That's clearly a capacitor in the line that runs from the oscillator coil up to the grid of the mixer tube. Nothing unusual about it, except let's look at number 5 in the parts list. Here's number 5. Oscillator transformer. Doesn't say anything about a capacitor. They've been writing the value of capacitors next to them on the schematic. Why not this one? Why no value there? Excuse me. So I went hunting for this capacitor in the radio. We don't have to do that right now. You can trust me when I tell you this is just a piece of wire running from the tube pin here. It runs tight around the tube socket and then lifts up to go to the coil. It actually connects to the lower part of the coil, so it doesn't lift up off the chassis very high. So I started wondering, well, what is this supposed to represent then? And the only thing I can conclude is that they're trying to suggest that there's some capacitance in this wire. But you know, that doesn't really make sense, because you wouldn't show it like this. You would show it. There are ways to show wire capacitance. One way is, excuse me, you draw the capacitance symbol. So one plate is here and the other plate is over here. And then you connect the fake capacitor to ground like this. Something like that. Give you some impression that there's a capacitance between the wire and the chassis. But this is showing the capacitance in series with the wire. There is no capacitor there, for sure. So I thought, well, maybe what they're trying to say is you have to think about the capacitance of this wire. Maybe if the wire is moved slightly, it makes a big difference in the overall oscillation. Remember, I was hunting for a reason why the oscillator wouldn't drop low. And I'd reasoned because I've opened the trimmer capacitor located here, that there's still too much capacity in the circuit. And I need to bleed it down somehow. That's a stupid way of putting it. I need to reduce the amount of capacitance. So I thought, well, maybe this is it. Maybe I'll move this wire, and presto. Of course, now I realize I was fishing in the empty lake. But in any case, I did move this wire around. No effect on anything. You could hardly move this wire. It's so tight in place. I also thought, well, maybe this is a gimmick. Okay, so a gimmick is where you take two ends, you take a piece of wire basically like this, you cut it, and then you twist those ends together without making electronic contact, so the metal of the wires doesn't touch. You just twist them around their insulation a few times, and that can give you a few picofarads. And this is commonly done, often in the front end of some of these radios. It's just a cheap way to get a couple picofarads. I think in making the radio, they'll put like 5 twists into the wire, and then during alignment, they'll nip back those twists a little bit until they get what they want, whatever that is. So I didn't get anywhere with this, but it still remains kind of a curious thing. What are they talking about here? But it's all a moot point now this morning since I discovered my mistake. Wow, it's amazing what a new day can do for you. So I carried on looking for some way to reduce the local oscillator and bring the pointer into the range that I thought it should be in. Bad boy. One of the things I decided I would try, and I really stay away from this, is to bend the plates. I've never done much of that. I'm not attracted to doing it. I think it's a factory kind of operation. You're bending the plates on the capacitors here to make the pointer track the dial correctly across its whole width. So you can get, you know, a radio like this, you can get it aligned at both ends quite nicely, but in the middle it can be out. So this plate bending thing helps you accommodate that situation. To me, that's a factory deal. Not something I want to play around with. I'm sure there's home repairers like me who do that. Thumbs up for you. Great. Well, I thought I'd try it. Oh, dumb me. While I'm bending the plate on this, I accidentally bent the plates on this one. I guess when I was levering or something, I didn't see what I did, but I collapsed one plate on the antenna side. That introduced a short, so halfway through tuning, the radio would switch off. And I hunted for that short in the oscillator side for a long time. This is why I didn't post this video, by the way. Now I'm really thankful I didn't. Hunted. Finally I got out the ohm meter. I looked for a short on this side. No. You know, between the stator and the rotor. I look for a short on this side. It shows a short all the time. Okay, so if you look at the schematic, you realize the reason for that is because between the rotor and stator plates is a coil here, and the coil is very low resistance, and my little meter wouldn't do it. So I brought out my this tester. Hooked it up as if to see a short. I was able to measure the microhenries that are in the coil by attaching it across the stator and the rotor. Well, when I tried that on this, on the other side, out of desperation, I just don't know what the heck's going on, I discovered the short. And then I looked at the plates, and for crying out loud, it was bent right over. Like, I straightened that out. And in the meantime, I also, coupled with all these mistakes, was me thinking, well, maybe I'll just determine how far out the situation is. Here's a little chart I drew trying to calculate 60 kilohertz out. But, well, you know what? Another part of the story is when I went to align these transformers, I found them aligned at 420, not 460. So, well, there it is. So somebody accommodated, this is what really got me into this, okay? Somebody must have accommodated the situation on the front by detuning the IFs and thereby allowing the pointer to get to the right spot. So, well, I'll do that. Well, you know, these things are really designed to resonate at their proper frequency, in this case 460. And you can probably push them some distance before you get a performance issue. But push them further than that and weird stuff starts happening. Plus, by the time you're off into this zone where nothing's going to get through, it doesn't matter what you do with these alignment screws, nothing's going to get through. You're misaligned with the front end. The whole thing is just going out of whack. That's exactly what happened. So lunchtime came. I literally gave up. I thought, oh my God, this has just got a horror story in every direction. But I came back in the evening, basically hell-bent on getting this thing aligned. And I managed to get it aligned by giving up on making the pointer go where I wanted it to go. Well, that was actually the right thing to do, wasn't it? I didn't know it at the time. So that's the status of the radio now. It's aligned. Chances are, if I put these marks in the right spot now, I'll find out the radio's actually quite well aligned. But clearly it needs a checkup. It's going to need a checkup, especially a local oscillator and the antenna, which it doesn't seem to have much effect on anything. So 600, 590 should be just below it. Tune my antenna here.
Todd Don QB plus a TD for Zach Pascal. I'm going to go with Amon-Ra St. Brown. I'm going to go really down the rabbit hole here for Lions wide receivers.
Wait a minute. He's going down the rabbit hole.
Points, including a touchdown in half or full PPR.
Okay, let's see if we can get that 640 this time.
Leading the Lions.
Checklist. Should be right here. Maybe just a little down. Check it using the signal generator. Pretty much right on. Okay, must be the antenna. There he is. Too much interference on top of it here, but I'm sure if you relocated this radio, use that loop antenna too, you get a great signal out of it. Okay, that's fantastic. Oh my gosh, now the hum. So the suggestion was, when I was using my signal tracer to try to identify where the hum was, and the result of that was the hum seemed to be coming out of the tube. I then swapped the tube, made no difference with the hum. So the hum must be somewhere else. Got involved with the rivets. Pretty hard to kind of prove the rivet problem without a lot of mechanical force going into something to wiggle the rivet and to change the state of affairs. Tried a little of that, didn't get too far. The suggestion is I should make a killer out of a grounded capacitor, large capacitor, and kill parts of the circuit, including rivets, everything, with this capacitor. You see the hand action there. So this is a very, very simple way of doing things. The reason for the capacitor is because you might touch something like a B+ line or something of that sort. So if you just did it with a piece of wire, you take much too much of a risk. So I'm going to make one of these up because there's nothing to it. Wire, a clip, and an old voltmeter pointer was the suggestion. I'm sure I've got some. So I'm going to make up a killer here. There we have it. The snuffer. There we go, the snuffer. Okay, now we don't want to use it kind of randomly, plus while you're poking around with this, you're charging up and discharging this capacitor. You need to be thinking about that a little bit, so you don't apply 300 volts briefly to a grid somewhere. That's probably not a good thing. Okay. I'm guessing you can hear the hum. Best way to help is I'm going to turn it off briefly. Oh. Action's up here now. Turn it off briefly. Hear that hum disappear? Plus I'm going to give it 100 and full voltage here. It's been running on. Yes, I did the alignment on a lower voltage. Made that a little bit louder. Okay, good place to ground this is here, I discovered. And away we go. Okay, get rid of this. Get rid of this. Nothing else connected. Yeah, I've got this connected here. These go to the speaker. We don't worry about that. Okay, first place to hit. Grids. Yeah, make the slightest sound. Turn it up a little bit. That's the key one there. So this hum is coming out here somewhere. Is that true? I think that would have to be true, I think. Out here being in the audio circuits. Just guard that a little bit. Oh boy. This looks like fun. We can think a little bit about this. This capacitor is the capacitor that conveys the signal from the plate of this tube to the grid of this tube. This is where I found the hum come and go, sort of, when I did the signal tracing. Come and go. Well, that sure quieted it. But here? Well, we found the spot already. We found the spot. So, to work back on this tube, to go back up, is to go to the grid cap again. Kills the signal, but not the hum. Killing it on this side of the capacitor. Really kills it. Okay, so I know what I knew already. So the hum must be coming from this terminal. It's being introduced in this tube. Let's take a look at the tube. Look at the tube in the manual. What tube is it? This is a what? I need to just glance at the manual here so I don't make a mistake. That's the 6Q7. It's the 6Q7, yes. 6Q7. I changed that tube with an alternate tube. Hum remained. So a hum would be maybe in the screen. Is there a screen? QRS 6Q7. Well, no. There's just grid, cathode, plate. We hit the plate, goes away. Cathode, I believe, is just grounded to the chassis. Pin 8. Pin 8. Pin 8. Pin 8. Where's the key? I got the right tube, yeah. There's the key. Pin 8. I missed it at first. So it doesn't do a thing because it's grounded. I got something worked out wrong. So these are the two diodes. Kills the signal, leaves the hum. And what about the heater? Oh my gosh, I put this on the heater? I don't know about that. I don't know, it's a big capacitor. What would happen if I put that on the heater? What would happen? No resistor. 56 volts. I'm good for a few seconds. That's my calculation. Look at the heater. How can the heater do this? 6Q. Q. Why don't you leave the book open, Jim? 6Q7. Heaters are 2 and 7. 2 and 7. Leave the book open. 2 and 7. 2 and 7. Well, I'm a little bit uncomfortable doing this, but let's give it a try. 2 and 7. 2, 7. Hum stayed. Signal went away. Wait a minute. 7. This is 7. 7 appears grounded. So 2. Here we go. Not a thing happening here. Alright, so we kill the grid, nothing happens. Signal goes away, hum stays. We kill on the plate, hum goes away. Isn't that odd? Don't you think that's odd? I can kill the grid and such a high level of amplification in the audio circuits that this tiny hum is coming through. Well, where's the hum coming from? So I have a shield missing on this tube. I wonder if I can find a metal version of this. 6Q7. 6Q7. I don't think there is one. 6SQ7. Well, 6Q7. I don't know. Metal type 6Q7. And glass octal type 6Q. Look at a metal one. Look at a metal one. I must have a metal tube somewhere. 6Q. 6Q. Here's my SQs there. Where are the Qs? Let's take a look and just see if I can do something dumb and stick them in here. These are all 6Q, 7s, and 12 SWs. For some reason I put those together. The SWs are in a bag. Is there anything in there with a grid cap? No. Wait a minute. Think, man. 6SQ7 means single-ended. Means there is no grid cap. The grid is down here now. Can you do something and stick one of these in? Why would I? That's too much. That's too much. I wonder. There is no such thing as a 6. It does say there's 6Q7. You'd think I'd have one. I have tons. I have tons of these 1940s, 50s tubes, as you can see. I've managed to acquire a lot of exactly the tube somebody would want. 6Q7. So I'm going to look in my listing here. See if I have one listed. I do not have any 6Q7s as I know already, including one like this, except for that Rogers tube that I popped in here and the hum level did not change. So are we talking about wires in proximity? Maybe like a grid wire running past a heater wire? Like, well, here's the grid wire up here, and I shielded it. And you can see it's not going near anything. I wonder if I got this. This is what comes just before the rubber mallet comes out. Well, we do have the big resistor sitting here. That's got some current in it. Would they have designed this radio to hum like this? You have a capacitor shoved right in here. It's connected between here. How do I find something better to point with? This guy is connected between here and here. What's this? This is ground. Well, what if this guy's job is to get rid of this hum? And he can't do his job because he's a sick puppy. We also have a resistor right here. It's also tied to this terminal. Resistor gone high. So resistor's carrying the B plus, I think, to that terminal. Well, that capacitor is a little suspicious. I can replace that. Let's take a look on the schematic and see what it's doing. That's some kind of a Mica type. Okay, so we're over here, and we're looking at a Mica capacitor. Where? No, it's on the plate. Oh, there it is right there. 250 picofarads to ground. That's probably the guy right there. He's probably the problem. Okay, 250 picofarads. Of course, I bridged this with a gigantic capacitor, and that certainly took care of the hump. Well, I can bridge it temporarily with a 250 picofarad. Or is the problem here that this is leaking? Or couldn't be shorted? That would be a disastrous situation, and the radio wouldn't work. A little bit shorted, a little bit leaky. Because ultimately he's heading for a grid. So you get a bit of hum in here. Alright, and what I was doing, I was killing out on either side of this capacitor. This has got to be the guy. I think this one's job is to drain out RF that's made it this far. Not this kind of hum. I think I'm going to remove it and replace it. 250 picofarad. Very good. Okay, I've got the replacement here. It's a slightly different type of capacitor, but I think it's okay. Let's go in and cut it out. Yep. Bound to replace it. I found these capacitors to be very reliable, but time to time. Of course, this one's tucked up close to this warm resistor here, what I assume is warm. A little more wire. There he is. We'll give him the test on this. What was this supposed to be? I can't remember the value now. On video, it's just been a moment, right? But in reality, I've been doing stuff around the house and that. Enjoying the beautiful sunshine that's come out. What do you say? Probably going to say it's okay. Read it and weep. 223 picofarads, loss is nothing. 220 picofarads. And what was it supposed to be? I have to look. I cannot remember. It is supposed to be 250 picofarads. So this is not the problem. Jeepers. Hate it when that happens. Okay, well, we'll stick another one in there. I'll probably end up with more hum. That's what I'm gonna guess is gonna happen. I'll just leave it running here. It's really tucked in there. Unplugged. Oops. Let's see if I can. See if I can finish the sentence. Okay. Okay, fire up the soldering iron here. Imagine if you walked into the place where they were building this back when they were building it. You walked up to the man or woman with the soldering iron in their hand and said, someday those soldering irons will have computers in them. They would say, what planet are you from? What are you talking about? Computer? I'm working on just started work on a jukebox in a person's home. I've already told them I don't know what I'm doing, but they're happy to let me try my best on it. In this jukebox from 1950 something, 1956 I think, is a memory system based on donuts on a wire mesh. Now, if you know what I'm talking about, great. If you don't, very early large-scale industrial scale computers like the IBM 360 and others had a RAM memory which was made up of a screen, and the screen has wires crossing, and there'd be a donut, a magnetic donut around every intersection. You can fire signals in on these wires and cause a magnetic and magnetize the donut. And then for reasons I can't explain, I don't know exactly, you can then read the way in which the donut's been magnetized, either this way or the other way. And that's the 0 and the 1. And this jukebox has this memory system in it. So I don't think too many people would realize that jukeboxes, as much as we don't think, well, I don't think about them at all these days, but we wouldn't think of them as being really high-tech machines. They were stupidly complicated machines too, just really complicated. I mean, at the same time, it's got this state-of-the-art memory system in it. That's for remembering numerous choices. So you can go up and, I'm pushing the buttons here. Pick that record, and pick that record, and pick that record, and this thing would be the memory system for it, as I understand it. Hard to believe that kind of technology was in a jukebox. It's a Seeburg KD200, I think is what it's called. I'm in the process of reading the manual for it right now. I have a little bit of experience with jukeboxes, and basically the last one I worked on, I said never again. I will never go near another one of these again, because there is so much in them, especially a jukebox been in somebody's home for 30 years, 20 years, and everything is dilapidated. And even though it has the modern memory system, it also is full of relays, full of multi-contact relays that are almost timed in the way they operate. You have to have very precise distances between the contacts. Yikes! It's stunning to me that any of them work, and I'm not about to. I know I should have covered this wire. Son of a gun, that was dumb. I should have covered this one here. Well, it's not going anywhere. Oops. So, jukeboxes. Great, big, monstrous machines built like automobiles. Weigh a ton. A jukebox expected monthly or bi-monthly maintenance from a guy who would come around to the restaurant, and usually the jukebox not owned by the restaurant, owned by a jukebox company, and their technician would come in and he'd perform the maintenance and keep everything up to snuff, so you didn't have 1,400 things going wrong all at the same time. But if these things hadn't been maintained, They've been sitting around, maybe used occasionally, and all of a sudden they don't work, and then people usually just leave them for years. And then one day they go, well, let's get that jukebox going. Oh my God, there could be so many things wrong in there. Very, very complex machines. Okay. Easiest thing to do is to take a Bluetooth receiver, stick it in the audio part of the jukebox, and then pick your song on your phone. You know, do away with the whole mechanism. But people love to see the mechanism operate and pick the record and stick it on. I mean, that's the whole thrill of a jukebox, right? Thrill. It's the thrill. Very good. Well, let's see what we got. I think I'm going to leave it tipped up. Everything looks okay otherwise. Okay, volume down, because who knows, plug it in. This is the test. The test is proceeding. Here comes well, I'm pretty much at my wit's end here on this guy. Does it seem any less? I think it's exactly the same. But she does live. It works. And the level of hum, although when I put it in the cabinet it would be a little higher, is a range where if you're listening to something you won't know it's there. That's what I'm going to tell the owner. Oh, I just told him. I cannot get rid of it. It's also just possible that... Oh, there comes that terrible noise again. Is it this resistor? What is it? Just turn it on and wiggle the tube for a while. I don't know what it is. Dirt in... No, that would make sense. It seems to go away and the set heats up. That's why I'm suspicious it's this resistor here. So I'm not sure working it mechanically is going to reveal anything. Something's bad. Something bad in there. Give me something stiffer. A stiffer thing here. Yeah, let's crack this resistor right open. Careful, man. Careful, careful, careful. And there we are. Nope, it's back. What is it? Where is it? Did I figure out it was in the audio? I didn't do anything. Oh yeah, I did. Got to be in the audio circuits. Well, too late now. That can be a tube very easily doing that dance as the heater is heating up. Could be something to do with the tube cathode, the heater cathode situation. It's good now though. We'd have to stick different tubes in here and then play the radio and see if the effect comes or goes. Probably not a good sign in terms of longevity for a tube if it's a tube doing that. I think I'm done. I'm going to stick this guy in the cabinet and we're going to find out what happens then. Okay, let's see how this goes here. Put a new light in it. Can we see it? Oh, that's not too bad. Maybe make it even darker in here and really get a look at it. Very nice. There's that dastardly hum. Some people think, that's part of an old radio, right? We're going to do this on full power. Hey, it's even brighter. Yeah, I wish I could have got rid of it, but... Now, for an antenna, we're starting off with a piece of wire going nowhere. That's our first try. Oh, listen to that. Not much use going any higher there. Okay, next attempt. Yes, I don't really have a long piece of wire handy. I have an extension cord. So this is a long extension cord, lawnmower type extension cord. And it's just played out through my house on the floor behind me. So it's quite a bit of wire here. Might as well just use the ground terminal on it. So this is the long wire antenna technique here.
This seems too easy. This seems too easy today just to take. Again, it'll be a juicy
640? No. 590 way up at 610. There's nothing up here. Now, all that effort didn't make it. Didn't get it to line up again. See, my knob is slipping. The string is slipping a little bit. Okay. New idea, not a new idea. We're going to put on the loop antenna here. This loop antenna I'm using, basically it's a coil that you tune, and then the coil becomes very, very sensitive to the frequency you tuned it to. And the coil picks up the signal and rings with the signal coming from the station. Then there's a pickup coil, usually just one turn, maybe two turns, that picks up that signal from the coil and then delivers it to the radio. So that's what I'm hooking up right now, is the delivery coil. Wait, I need to ground this. There's no easy access ground here. So I'm going to go right on the screw at the top of this can. I should have extended the ground wire out. With a good antenna, this is what you can expect from this radio. Good antenna being a loop antenna. Everybody stay connected.
Enjoying my cocktail. Not JP, what is it? Very old fashioned. Timeless drink. We gotta make some room in this garage. Your board games?
Chuck 'em. Your total body home.
See ya. Your encyclopedias?
Good riddance.
Hey.
This is the antenna I'm using. Why did it go so quiet? I was reorienting the antenna, and all of a sudden it went quieter. Don't like that. Maybe I bumped the tuning? Yeah. That's what happened. It's definitely a fight against the noise signals. And noise signals here are much, much stronger than the radio signals.
Maintenant, les femmes se mobilisent au Québec aujourd'hui pour réclamer de meilleures conditions de vie. Les organisatrices de l'événement ont présenté ce matin leurs revendications lors d'une conférence de presse.
Well, not bad. Too bad about the hum. I just cannot get it out of this radio. Too bad. But it's working. And there we go. That's great. Now the next radio is another AM radio, which I hope to do very quickly. This one took twice as long as I had hoped. Next one, I think I've had it in my shop for one video. It's a farm radio. And then I got into discussions about, well, it's a battery operated radio. And the owner, he knows about this kind of stuff. And he has some battery, there's a word for it. Back in the day, a lot of radios were battery operated. And then somebody invented a power supply you could plug in the wall. And it had wires coming out of it, which you would then connect where the battery was. A battery replacer, a battery substituter. I can't remember the proper name for it. He's got a couple. So he wants me to carry on with his radio, fix it up, and I'll just drive it with power supplies here in my shop while it's here. And then he can drive it with power supplies. So, okay, well, not the best, but at least it's working and it looks good, and I think he'll be happy with that. So thanks a lot for watching the series, and we'll see you on the next radio. And then after the farm radio is done, it's back to that FM receiver, and I've been busily reading up on FM radios from that time. Thank you very much for those of you who sent me stuff to read. Wow, reading that kind of stuff, it just highlights how little I know. Great. See you on the next video.